right? Because, so that's why I'm saying those days it was not that difficult to find jobs. Nowadays it's a real challenge, and in fact, from jobs, so once you get the job, then in terms of what you do as a faculty, work and so on, the landscape has changed considerably. So I will try to point out some of the things as I get going here. So Prashant wanted me to just talk a little bit about what research opportunities are there. And I just put down some R&D topics that, I mean, there's nothing that you have not heard of before. Now, I had some experience in actually, working out on some of these things when I was at NSF, because when you're at NSF, you're very close to the government operations. So, for example, I had an opportunity to work with Office of Science and Technology Policy. That is the place where a lot of the future technologies and how funding is going to be set aside, all those things get decided. So there's a lot of interaction that happens at that level with a lot of federal agencies. So NSF is one of the primary agencies that the government folks work with, and there are many of these agencies that are in Washington, D.C. So these are some of the things. So advanced manufacturing, of course, you've seen the President's emphasis on advanced manufacturing. So this is going to be here for a while. So that is something that you need to think about. Mechanics and engineering materials, all this emphasis on nanomaterials, the nanotechnology areas, resilient and sustainable infrastructures, systems engine design, so transportation, green buildings, environment, healthcare, so on and so forth. Like Drexel itself has picked 3 areas that, at least the College of Engineering has picked 3 areas that they're going to concentrate on. One is sustainable energy. So this talks about all forms of energy, alternative energy, wind energy, solar energy, all these things. Advanced manufacturing is another area. Actually, advanced manufacturing is going to be a focus for the mechanical engineering department. And integration of health and engineering. So this covers the waterfront in anything related to biomechanics and all these things. So we didn't want to call it biomechanics, because the biomedical engineering department separately, but integration of health and engineering in various forms. So what is important is, when you do your research, you need to have the bigger picture. That is, when you do research, you focus on some very narrow area. And in a way, you're very lonely, because you are the expert in that area. You will know more than your advisor. If you actually really do a good piece of work, you will know more than your advisor. But the thing is, you need to put this in context. How does this fit into the bigger picture? So that's one of the things that you've got to learn when you are doing your research. You have to always ask the question, where am I going with this research? If I solve these problems, so this is why, I mean, if I have time, I'll talk a little bit about what you want to do when you write a proposal to NSF. And NSF proposals require 2 things. One is obviously the things you do with intellectual merit. Intellectual merit has to say, what is new in what you're doing, why you're doing it, and all those questions have to be answered to be rated as a proposal with merit. And then you have to have the broad impact. That is, what good will it do to the society? As especially if you are in engineering, this is a very important thing. Now, so I want to just take a minute and tell you, when I wrote my first proposal back in 1983, we didn't have to do all these things. We didn't have to show the context in which I was doing the research. As long as I could say something scientifically that this is a good problem to work on, that's all that mattered. But nowadays, you will find that if you're writing a proposal and you want to get it funded, you have to be able to say the bigger picture. So that is, it's a lot different nowadays than it was many, many years ago. Now, in here I have this thing about robotics. So I want to just tell you a little bit. I'm not going to spend too much time, but so these are just various things that you can do under many of these topics. I'm just listing things that's not important. about trends in robotics. Actually, this is a discussion that happened while I was at NSF. And actually, this is a presentation I made at one of the OSTP meetings about trends in robotics. And the reason I'm putting this up is, as researchers in a certain area, you've got to know the key players in your area. The field that you are in is usually dictated by not too many people. There are maybe 20, 25 people that might guide a certain area. So you've got to know who those people are. So that's this business of networking. And this is where talking to advisors, attending conferences and meeting these people and forming a network is very, very crucial. Okay. So this, in this discussion, so like I said, many of the agencies were involved, DOT, NIST, Energy, you can name it, almost all the government agencies that funded research was involved in this. And the idea was basically to talk about robotics, because robotics is prime time in Japan, Korea, and some of the Asian countries, but not necessarily in the US. So there was a feeling that US was falling behind in terms of these useful technologies and what could be done. So essentially, it was a forum in which people got together, talked about things, and figured out what could be done. So the thing that I'm saying here is, so there are all these things that we talked about. We talked about what robotics had been. So like this is, you start from its history. When robotics first came into being, it was basically due to automation, manufacturing. Automation was the key thing, and it was used in automotive, aerospace, semiconductor manufacturing materials, and so on. But then started thinking about what it could do in a modern society. So you go from the history, and we will see that a lot of times what happens is these areas sort of go out of fashion after a while, right? So when you want to project for the future, now you have to see, okay, how can you benefit from these same ideas that were there before, but perhaps with new twists. So this is what we talked about in here. So like some of so here we basically say new trends and opportunities lie in the broadening the definition of robotics. So we expanded these things, starting from the simple idea of automation. So these are things that you should think about, because I'm sure many of you must be working on some of these subtopics. But these topics fit into some of these national initiatives. And currently there's a national initiative called National Robotics Initiative. So there's a lot of funding that has been set aside for the National Robotics Initiative. And people working in many different areas can come together to do proposals in these areas. So, and the idea of collaboration is again one of the key things here, because if you're doing these are very multidisciplinary topics, So when you're doing one advice I can give you is, when you're doing your PhD work, take the opportunity to attend as many seminars as you can. Listen to people of different areas, because you will find that somebody talking about a totally different subject might have an interesting approach to a problem that would fit into some of the things you're doing. So you can benefit by having that breadth, because otherwise you forget that there are other things that people do that are quite useful for you in your own careers when you want to go forward. So I'm not going to get into this, but these are things that you can do in this area. There are all these terms we have heard of, mechatronics, and this is some of the main driving themes for National Robotics Initiative can come from this topic of mechatronics. So there are all kinds of things you can do, mechanics, electronics, computer hardware, computer science, computations. So many, many different things that you do can fit into some of these key areas. So I'm just giving you National Robotics Initiative as one such thing. Take, for example, energy and sustainability. I mean, if you're an engineer, not just an engineer, if you are doing some other work, like for example, implications of the technologies in life, so you get social impact. So there are a lot of things you can do in terms of these broad areas. Okay, so this is just so like robotic applications that I'm talking about here. The new ways you can use robotics. So this is just like telesurgery, for example. These are robotic applications. I mean, some of these things are already in existence, but we are still working on this. Cargo handling, cooperative cargo handling. How you use multiple robots, smaller robots. How you get these robots to coordinate and do maneuver large objects and things like that. So there are a lot of interesting topics, as I said, in robotics. Here is some other things that I just put. This is in terms of emergency management. Emergency management is another hot topic. In fact, you know that in my department, Professor Paul O has a project with DARPA that essentially is geared towards emergency management. How do you use robots to do efficient emergency management? So there is so we are one of few teams that are competing in a DARPA Grand Challenge. So there is a lot of activity in this area here at Drexel. So this is just a cartoon from my days at the NSF. I ran the control systems program, so I used to give talks like this, and I would tell people what are big projects of importance or what are topics of importance to my program in control systems. Okay, so that is just to give you some flavor of what broad research themes that you could have. Okay, now let's say that you are going through your graduate program, you're finishing up your PhD, and now you're in the job market, looking for a job. So now you have to make a decision. Where are you going to work? So there are many opportunities. You can go work in the industry, you can work for a small business, you can work for a government lab, you can work for a university. So you pick what your passion is, but you've got to know what each of these things offer, right? Like, for example, if you are excited about interacting with students, you love to teach, then you naturally are going to look for university career. Now there again, if you are looking for a university career, and sometimes you have people who want to be in a university, but their passion is teaching. They don't want to do research, but the passion is teaching. So you can make a distinction between a research university and a teaching university. So you could get into a situation where you could just simply teach. Or you could decide that, no, I want to be in the industry. I like to apply my knowledge in technology development and so forth, right? So then if you have to go to an industry, like there are major industries, like big aerospace companies and also who invest a lot of money in doing research because they have to sustain their businesses, they have to find new markets, new products and so forth. So there are a lot of these companies that invest in business. So if you go to a big company, that's one of the advantages you have because they will have research funding that can be made available to do research, to develop products that are of importance to them. Now, you may also have a situation of joining a small business, small company. Now, one thing to keep in mind is that many of the small business companies that you will go to work for, your job depends on what you do. Right? You basically are required to write proposals, get them funded. This is where you have the small business innovative research initiatives that are all over the place in various agencies. You write these proposals, you get the funding. That funding is what is going to pay your salary. So it's a challenge, but it can be very exciting because if you have some ideas that you would like to develop on your own that might be useful for such a company, it makes sense. But then you might ask the question, why don't I start my own business? Right? That's also an avenue that is open to you. If you create things as a graduate student, sometimes in your own research you find that, okay, this could have I could develop a great product out of this, and I can have my own business. So those are other opportunities that you will find, right? Now, you will also find the federal government invests so much money in research. So that is why you have PhDs working at government labs, okay? So there are a lot of opportunities at government labs, and if you're at a government lab, more often than not, you end up actually collaborating with universities, and you have an opportunity to keep your research interest going, right? And the other thing you will realize is that if you work for an industry or a small business or a large company or lab, sometimes you don't have this opportunity to publish your work because for obvious reasons, because of proprietary reasons. You're not allowed to publish certain things, which is quite different from if you were to become an academic, right? Especially if in the engineering field, if you were to become an academic, the pressures that you are under are so different from what you would have otherwise, okay? Okay, so I'm going to just talk a little bit about academic careers because I am an academic, so I can tell you, different stories about academics. So the first thing is, if you want to be an academic, you decided that I want to be a professor, right? So the first thing you want to know is, how do you get a job to be a university professor, right? So we already heard things. So one of the key things when you are applying for a job is not wait until you finish your PhD. You start early, right? So you have to decide. If I'm going to apply for a university job, sometimes the question is, should I do a postdoc, or should I apply directly from my, PhD? So how do you make this decision? So, a lot of times you see, I can tell you by looking at applications when you advertise for positions, we get applicants all over the place. We get some applicants who may have published, some of these applicants have 30 papers they have already published, right? But then you also have others who have not published that many papers. So how do you make the distinction? It's true that if you have a lot of applications, somebody will look at your application. But even if you don't have that many publications, your application can still be looked at if the research you had done is very significant. So you have to make the case that your research is unusual and it is significant. Okay, now this is where I think your networking becomes very important, because if you attend a conference, let's say you did a paper, you go to a conference and you present this work, it's people who are working in similar areas. You make the presentation and you create an impression that people recognize that this is something really fantastic. So if you did that, then people will make notice, take notice of what work you did. Okay, so it's how you package your thing. It is, when you write your application, you don't want to say that, okay, I have published 30 papers. Nobody cares if you publish 30 papers. If you cannot tell what is so special about your publication, what is the area that you research, what are your new findings, So if you can make an unusual case, then you stand a strong chance. Okay. Also, networking is important. So sometimes I think, although it is not emphasized, but the person you work with can also be very important. Recognized person in the field and somebody's student, that can help you also. Now, I'm not going to say that if you send a blind application, you just apply to any position that you are going to get called for an interview. It can happen, but it happens very rarely. You have an unusual case to be able to have that opportunity. So, I can tell you, we just advertised for 2 positions. And I sent the ad out to ME department heads. So a number of them I know who these people are. So they in fact wrote to me, especially, okay, I have such and such students. So they sent me, you may want to look at these students for your position. So this is what I'm saying in terms of networking. So if you are trying to know what you're doing, what good work we have done, when you get an opportunity like that from somebody who's known to someone, that can help you. So networking is very, very important. So take the opportunity to attend conferences, and if you're presenting a paper, that's great. Even if you're not presenting, if you have like for example, if there's a conference in the neighborhood here, New Jersey or Philadelphia somewhere, you might want to just attend, because at least you get to meet people. See, networking is vital, because just first to get a job, okay? And even after you get a job, now you have just started. So let's say that you landed a job in a university, okay? So the application, so you have to, each job will usually get about 100 applications, so you can just see what your odds are of finding a job. So about four or five people may be interviewed for one position, right? So you have to be able to get into that first cut if you're going to stand a chance of interview. So it's not easy to find these jobs, so that's why it is important that you concentrate on the work you do. So I sometimes tell students, I have my graduate student here can tell you how what kind of work I ask him to do, but there are all kinds of research people do. Sometimes it's unfortunate that graduate students are considered to be cheap labor, right? So there are sometimes if you end up going into somebody's lab and just collecting data, okay? So if you end up having to do just that, and you don't know where it is going to take you, I think that's a waste of time. So, if you're just collecting data and you don't know what you're doing, it's just plain and simple labor. So you need to ask yourself questions, why am I doing this? And this is where you have to have interactions with the advisor to understand what is the significance of things I am doing, okay? Or, because you will be under the same stress when you get into a faculty position, because once you have a faculty position, the next thing is you want to earn tenure, right? Now, being a professor, tenured full professor, is the closest you can get to complete freedom. Right? So that is why sometimes you see that people who become university professors, so once they have tenure, of course, the reasonable assurance is that you will have your job for life, although things are changing somewhat now because you have, post-tenure review and whatnot. But, so what happens is sometimes there are people who, undergo this pressure, and you're under so much pressure, you've got tenure. You release the pressure and you don't do anything beyond that. So you end up what I call APES, Associate Professor Emeritus. Right? Never get promoted. So you don't want to get into that situation. You want to, if you're thinking of a university career, you need to make sure that you're going to go all the way. And because you have to first ask yourself why you became a university professor. Okay. Okay, so let me just tell you a little bit about, so let's say you are a professor, assistant professor. You come in as an assistant where you negotiated all your startup packages and everything, and now you came on the faculty. So now you're told that you have 7 years to earn tenure, right? But that actually is not true. You really have 4.5 years to prepare your package to say, okay, I'm now ready to be promoted to associate professor with tenure. Okay, so it's you can see 4.5 years is a very short time span. So you cannot idle. You have to do all the things that you are supposed to do. So what are the things that you are expected to do? You're supposed to do some teaching. Of course, new faculty, if you join a research university where you're expected to do research, invariably you will get a reduced teaching load. Meaning typically you are given one course to teach a semester. Okay, it depends from university to university, and this is how you would compare offers also. Sometimes you have multiple offers. These are some of the things that you can look at. So you are given reduced teaching load because you are expected to do something that you perhaps have never done. Some schools, of course, allow PhD students to become instructor of record and they can teach classes and get some experience. But anyway, when you get into a university, that's the first time you actually have total responsibility for a class. So you're expected to develop this class. Not necessarily a new class as far as the curriculum at the university is concerned, but it's a new class as far as you are concerned. So you have to put in some extra time and you are expected to put in that extra time. Now sometimes in some schools there's a myth that if you are joining a research university, that teaching doesn't count. That's not true. At least in my book, as department head, everywhere I've been, that was very, very important for me. So I look at somebody doing a very good job of teaching, meaning in terms of how you prepare your course notes, how you exam students, what extra effort to put in. All these things count because I think it helps you, in my view, it helps you to continue to be a good researcher if you spend the time doing these preparations for the classes. Because as a researcher, what you do is you are in the business of learning yourself. And you keep learning, right? I mean, otherwise, so that's what I call the difference between a community college and a university is exactly that. Community college, you don't expect the teachers to do research and impart that knowledge to you. But in a university, you expect people to do the research and bring the research experiences to the classroom. So teaching is very important. Don't forget that you have to do a good job of teaching. It's not just getting good student evaluations, okay? But it is what you teach the students and how So I mean, the first time you teach, you might teach it one way. Second time you teach it, you will improve it, you will find, you learn from the feedback. And you have to demonstrate that you have been doing this. That's part of the research in teaching, if you will. Okay, so the other area that you will be judged on is research. So the key thing here is without publishing, it is impossible to gain tenure. What does that mean? So again, there is a different people have different ways of measuring research publications. So what I tell when I have junior faculty join the department, what I usually tell them is, if you publish 2 quality journal papers a year, you are doing well. Okay? So what that means is that if you come up for tenure, let's say in 4.5 years, 5 years, so if you have, don't want to do bean counting, but this gives you some idea of what it is. There's a joke that says, sometimes it says, when an assistant professor comes for promotion, they say, how many papers should I have? The joke is that you should have n+2, where n is the number you have. So the point there is that publications are very important. And also one other thing you need to keep in mind is when you say quality publications, nowadays you can publish anything. All kinds of journals you can publish. And there's a lot of garbage being published also. So you have to be careful where you publish your work. So it's important that so there are, like if in your area there are certain journals that people, accept as quality journals. And it may not be easy to get things published, like she said, some journals take, years to get a paper published, And so you have to make a balance, So you have to, at least you have to show that you are capable of publishing good work in good journals, And in engineering, of course, we expect you to attend conferences, publish conference papers. So pick good conferences, conferences where papers actually are reviewed. Okay? And then the third category is service. So the 3 areas that I have to do well: teaching, research, service. Now, from a starting assistant professor, the service is not, you're not expected to do that much of service, but you're still expected to do something, be a good citizen for the department. So in the department, you serve on a curriculum committee. So you'll be asked to serve on some committees. Hopefully you won't be overwhelmed by committee work. But more than that, what you have to do is you have to try and get engaged in society activities, professional activities. So join your, whatever, let's say if you are in ASME and you are a mechanics guy, make sure that you join the mechanics division and get involved in the mechanics division, right? And try to get on program committees, okay? Try to get on the technical committees. So this is something that you need to develop as you get into a university job. Because why is it important? Because at some level, external reviewers are going to be asked to evaluate your case. So they're going to ask people to say, okay, tell us something about the research work you are doing, right? So they have to know what you're doing. So people who write letters for you, they usually will be from your discipline. So you have to make sure that you somehow or other make the connection. You get introduced by somebody and so on and so forth. Let them know what kind of work you are doing, because I mean, when you talk about research, publications is one thing, but again, remember, doing these publications become easy when your research is funded. So that's the other thing, research funding. Research funding is, it's impossible to get tenure without research funding. Okay. So that is why it is important to know how to write a good proposal, and that your work, or you are somewhat other known by people who might be reviewing your proposals. That again goes to this idea of networking, right? So they know about your work. And so these are some of the things you have to keep in mind. So networking is a very crucial thing. Just graduate student networking is good, but you have to go beyond that. Network with the community. Okay. Yeah. So like for example, I have seen letters like this. Like for instance, a reviewer would write on a case when they don't say anything very strong, but they can say, this person deserves to be promoted at such and such school, right? The moment you see, these days when you ask for letters, people very rarely write negative letters. But you read between the lines. What it says is that if you say that you are good enough to be tenured or promoted at such and such place, it implies that this person may not get promoted at some other place, right? Especially if you're asking for a person to write a letter from a peer or better institute. That's the implication. So you don't want to have that situation. You want people to say, okay, this person would get tenure no matter what school he is at, whether in MIT or whatever. So that's the kind of letters you need to have. What that means is you have to take very seriously the work you do, the quality of your work, the significance of the work. Now, of course, if you have NSF funding or funding that is competitive funding, peer review funding, then you have a leg up basically. Then people know already that your work is good enough to be funded. Somebody is willing to put money in your work. That's a good indication. So like I said, the motivation should be, because that is the closest thing to complete freedom you can have. So if you go that route, make use of the opportunity and do the best you can. Okay, so this is all I'm going to say at this point, but I'll be happy to, if you have any questions or if you want me to elaborate on anything.
I want to repeat it, this perhaps was more important than needed for you at this point, but everything that was said in the last few minutes will be very important if you decide to stay in academia. But even if you don't stay in academia, remember the quality eventually will rise up compared to the competition. If you do quality work, everything at the end will come together. You're going to get letters from your colleagues that will be forced to say that you're an extraordinary individual. When we were discussing about letters, as part of the tenure process, when you go up for tenure, you need to present a certain number of references. And typically are professors from other institutions that have to look at what you've done, accomplished, and have to decide if you should get the tenure according to their opinion or not. If you do quality work, they will look at your publications and they will recognize that you did quality work, but they will look at your publication. If you do extremely good job, but you don't put that extra effort, that sometimes is a lot of effort, to publish it on a paper, you don't market yourself. Our way to market ourselves in this moment is to write papers. The importance of writing papers is also to transmit all the hours that you spent in your lab or thinking in your little office about what you've done so far. If you don't put this effort together in a paper, that thing will be lost. Basically, it will never happen. It never happened in the past. You did a lot of sacrifices. You woke up at 6 in the morning, showed up at Drexel, did a lot of work. You don't publish. That thing did not happen. You didn't exist academically. Unfortunately, that's the reality that you're facing. Wednesday academia is very important to publish, of course. You please, go ahead and ask questions.
I have two questions. First, you said that many people said if you have a good advisor, it makes life easier. Yeah, I agree, but there is another concern, is if you have a very good name of advisors, he, for sure, very big of your success is because of him, and this is partially true. But how would you show independence to the committee or to the people who are reviewing that, no, it's not just because of my advisor, but because I'm good at it? So this is one question. Second question, as an NSF director, for junior faculty or for, you said the field, or each field is dictated by 2025. So how should the small fishes get some fun? So should people collaborate with big names in the beginning, trying to get fund, and then be like depend on their own after that, or how should this be?
Yeah, so I think, so it's a very good question. So, I mean, there's no one way you can do this, you should certainly learn how to write good proposals. So one way you can do this is, and this is the role of mentoring. So, if you have good mentors, sometimes, if you work with good mentors, you can write, you can get to know how to write a good proposal. Sometimes mentors can help you connect with people that they know who would be interested in your work. So you can so you're an understudy under a senior faculty, so you do that, so then you learn the ropes essentially.